All right, we're up to version 1.4 now. I bumped up the version to uh, just a minor version to indicate that we made some improvements, and that's this script option here. So we have a script load from file and script run. So let me just demonstrate what these do. I'm just going to draw a little circle here, and I will load the script. And the script is in our temporary folder. It's called rmscript1. That's this file here. And once it's loaded, I just run it, and we can run it multiple times from this point on. So the first thing the script asks us is for a file name, so we can navigate to whatever directory we want the output to go to. I'm just going to leave it in the temp directory. I will call it test1 PAS. And it's telling me that a file already exists. Yes, overwrite. And our script finished, but we didn't see any indication that the script finished. It just did its thing. And if we jumped into Visual Code here, I will load up the file we just created. So it's in our temp folder, and it was called test1 PAS. And so this is what we created, this bit of code here. And the script that did it is located right here. And it looks like Pascal code, and it is because we're using Pascal script, and it's for most things identical to things like Turbo Pascal and Free Pascal if you don't use some of the advanced features. So standard functions and variable assignment and all the general stuff works pretty much the same way. Now, there's a few things that I've added to the standard Pascal script, and one is the option to get a save file name. We also have a get open file name. The difference between the two is that the get save file name will ask you if you want to override any existing files. So we just saw that prompt come up. If you use the get open file name, it will not give you that prompt. So if we just go through the script here, I've added some more functions. Let me just list them all here. So these are all the functions that I've added to the standard Pascal script. So if you're already using Pascal script in another program, um, these are the new functions that I've added. There's a put pixel, get width, get height, get the get open file name and get save file name, which I was just going over. There's a show message. I'll demonstrate that. And we have a bunch of functions starting with CG, which stands for code generate. So we have code generate open, uh, code generate options, and code generate close, and code generate write, and write ln, which is write line or write line feed. And we have a couple more, which to write a byte or write an integer, and finally get select area, and I'll show you how that works. So if we go back into the code here, so we saw this function being demonstrated. Let me just change the name here so you see where all these values go. So I'm going to change this to code, and I will save it. Let's change something else as well. Let's change the output format. Instead of hex, let's change it to decimal so we can see something obvious. So let's save it again. And if we go back to our program, we need to reload this. And I'm just going to keep the same file name. And let me go back and do one more change. So down at the bottom here, I have the show message commented out, but let's show a message after we generated the code. So if we go back here, let's reload again because we made some changes. All right, so if we run it now, we should see the file dialog to select the file name, and then finally once it runs, it'll show us a message. So let's see how that goes. So I'm going to override using the same file, test1. Yes, I want to overwrite. And it finished. So that's the message we get, code generate for your image. And if we go into Visual Code and look at our file, you can see that the array here changed from having hex values to decimal values, but everything else stayed the same. So there's a bunch of options that we can change in our script to make that look different. And so we can change the indentation, the amount of values per line, and if we want to indent on the first line. And so we have some flexibility, and we could change whatever language. Let's suppose we wanted to do this in C, we would change this to C len instead of Pascal len, and same for basic. Um, we'd have to modify the portions that we generate here as the part of the comment and uh, array definition, but all the code that goes in between that. So everything, let's just change it to C, so we can see what happens with the values. So let's change it to hex because C uses a different method to represent hex. And so let's go back, reload the script, and let's run, overwrite. And if we go, no, that's not good. I think we found a bug. Okay, let's all right, that wasn't supposed to happen. Uh, let's see if we can fix this. Yeah, that looks right. CLAN. And let's check out our script. Ah, well, that shouldn't have broke it, but I did put an extra L in there. So let's save it. And let's recompile our program. And let's redraw everything again. Script, load from file, rm script. All right, so let's hope this time we don't crash. Test one PS. Yes. All right, so no crashing this time. And let's see. So we can see now the code starting from this point on. Basically, we're getting the C representation of the hex value, and should be able to do the same thing for basic as well. So if we wanted to generate basic code, change this to basic, save, reload the script, and run again. And here we go. So this is the basic version, and you can see there it's actually data statements. The only thing you have to change is the generation of the initial code for your comments and defining how your array structure is. For basic, you wouldn't define an array, you just leave that blank, and you wouldn't include this end piece here. So if we go here, you wouldn't include this in your code generation for basic. You leave this out. And so what we're doing here to generate all this data, we're grabbing the pixel value. So we're using the get pixel value and then just dumping all that using the CG write byte. And that's how we're getting all this data here. So now what this means is that you can write your own scripts in Pascal Script and generate the code for any retro programming language or even another modern, Python or whatever you like. The only condition is that it has to be in Pascal script for now. This is something the Lazarus development that's included. I'll look into adding maybe a basic dialect in the future if I find something that incorporates well. But this is really a good option for all the formats that I don't plan to support on my own. You could add your own at this point. And if somebody has a problem implementing something in Pascal script, let me know. I can help with this bit of code here. But basically, this should be a good example. Let's try just a new script. And we'll do just a simple plotting of a pixel. I'll call it ARM script 2. And let's see if I can do this without breaking anything. So let's just plot a single pixel on the canvas and let's say location 2, and we'll make it color 15, which is white. So this should plot a single pixel. Let's save as in our temp directory. Let's change the extension to PAS. No, PAS. All right. And let's clear this. And now if we load the new script, ARM script 2, and run it, there we go. We have our single pixel there. And this is just a small demonstration of what you're able to do in the script. You could make this even bigger by using variables. So let's say you want to do a whole filled box. Let's do let's 0 to, let's say, 15. And let's change this to IJ. And hopefully this works first time around. Let's again clear, load script because we made changes, and run. Well, that was probably not a good color, but it because we can hardly see it. But let's go back and change the color. Let's try. What's a good color here? 2. That'll make it green. All right. Let's try 2. There we go. And so that's just some of the things you can do now. Now you could write code to create, let's say, buttons instead of just a green box like I did here. it will require more code, but now you have an option to do that. There's also a way of getting the coordinates, and so we can highlight a specific area. And if we go back to our other example, the first one, here's how to use that. You can use the get select area, and it takes 5 parameters. First one to tell you if it's active, which what I just did here makes it active. So if we selected an area, it's active now, and the x1, y1, x2, and y2 coordinates, just like it shows here, will be passed to this function. So you can take these values and basically substitute them in for whatever you want to create. So if you want to create something uh, using the supplied coordinates, then you could put that here and generate only a button, let's say, of that size, as opposed to filling up the whole area. And so there's probably a few things I'm missing, but give it a try. This is, I'm going to expand this so we can attach these scripts to buttons, maybe give an option to supply the coordinates by doing a similar effect as I do when we specify, let's say, line. And we could pass these coordinates to the script, maybe the same as a box, rectangle, or even a circle. We could supply these to the script. We get the option to first supply these by doing some kind of mouse pressing down or a hotkey, and then it gets passed to the script. So I could enhance it in the future, but for now we got basic script functionality. So that's it for this video. If you have any questions, let me know, and thanks for watching.